Hi, this is an explanation for problem 61 in chapter 14. In this problem, it reads a 100-gram ball attached to a spring with a spring constant of 2.5 newtons per meter oscillates horizontally on a frictionless table. Its velocity is 20 centimeters per second when x is equal to negative 5 centimeters. What is the amplitude of the oscillation? Now, to solve for this, we're going to need to figure out the frequency of the oscillation first, because the next equation that we're going to use has that in it. So to solve for the frequency, it's simply going to be 1 divided by 2 pi times the square root of k divided by m. Now, k is going to be our spring constant, and m is going to be our mass, which were both given to us in the initial problem. So 1 divided by 2 pi times the square root of 2.5 divided by 0.1. When you run the numbers on that, it comes out to 0.796 hertz. Now we can use that frequency to plug into the next equation, which is a is equal to the square root of x times t squared plus v times t squared divided by 2 pi f. A lot of different things there, a lot of moving parts, but basically we're just going to plug in negative 5 centimeters squared plus 20 centimeters per second divided by 2 pi times our frequency that we just solved for. Take the square root of all that stuff. When you run the numbers, it comes out to 6.4 centimeters right here. So that's what the amplitude of the oscillation is. Now for part B, it asks what is the speed of the ball when x is equal to 3 centimeters. Okay, so for this equation, for this problem, we're going to use the equation the final velocity is equal to the square root of the initial velocity squared plus k divided by m times the initial x value squared minus the final x value squared. Initial x is 5, final x is 3. So when we plug in all the numbers that we've got, our final speed is going to come out to 0.283 meters per second, or if you wanted to convert it back to centimeters per second, it would be 28.3 centimeters per second.